In this session, we will discuss about the linear regression, a simple linear regression. And it is one of the two types of learning. It's one of the two types of supervised learning, the other type being the classification. The simple linear regression is useful to many problems in the real world. Don't underestimate linear regression because many problems have a relationship which is simple. There are two types of variables. One is the independent variables and the other is dependent variables. The independent variables are denoted by uppercase X. They are the inputs to a system, to a machine learning system. These independent variables are called either predictor or explanatory variable. They are denoted by uppercase X. The dependent variables are the response variables, which are denoted by a lowercase y. It's only by convention. You can use either way, it won't affect the machine learning problem. The dependent variables, they are values that change due to changes in other variables. See, the independent variables, they don't change on account of any other variable, where the dependent variables, they change on account of other variables. This is the essential difference between the independent variables and the dependent variables. So they analyze a specific relationship between the two variables, between the dependent variable and the independent variables. You try to set a relationship between these two variables. How the dependent variable varies with change in independent variable. So through this, we will gain a lot of information about the dependent variable through variation of values of the independent variable. Let us take an example of a situation where the linear relationship between two variables exists. What you see is a graph. You have on the x-axis the hours studied by the student, and on the y-axis the marks scored by the student. As you can see, there is a kind of linear relationship between the hours studied by the student and the marks he obtained in the examination. There may be exceptions, but you don't have to worry about exceptions. In most of the regression problems, we don't worry about the exceptions. We rather exclude them for analysis. We try to find out the majority of the cases how the relationship exists. There is another example of a linear relationship, that is the memory used in a computer system. Assume that it's a multi-user system where the number of users can log in simultaneously. Each user will require some memory for solving his problem. So when each user logs in, some amount of memory is consumed. It's not consumed really, it is allocated to the user. So as the number of users increase, the memory allocated will keep on increasing. So you can assume that there is a linear relationship between the number of users and the memory allocated by the system. So these two situations or many similar situations can be modeled by what is known as a linear model. The linear model, on the x-axis, you have the independent variable. Here I am considering a problem of cost of a house. On the x-axis, we have the size of the house. It may be in square feet or square meters. And the cost of the house on the y-axis. So independent variable is the size of the house, and the dependent variable is the cost of the house. So we try to study or collect data about different houses or many houses, their size, and the price paid by the buyer. And most houses sell for, say, minimum of $25,000. Can be any amount. And building each square feet costs some amount. Say let's call $75 per square foot. Then you will get a straight line like this, where the line cuts the y-axis at $25,000. It intercepts. It's an intercept. And you can also make a relationship saying house cost is 25,000 plus 75 multiplied by the size. So house cost is determined by two factors. One is a constant, which is 25,000, and other is a variable which varies with size. So building a house costs about $25,000 plus 75 into size of the house. So such a linear relationship can be set for the house price. However, the house costs vary even among some same size houses. In reality, when you try to see, you can't really say a 1,000 square foot house will cost the same amount always. I'm talking about the same locality. I'm not talking about different localities. Even the same locality, the same number of bedrooms and same features, but still the cost may vary. So we have to account for that. Look at this. The size of the house is the same, but for instance, in the first instance, there are four different costs. The second instance, there are four different costs. And the third instance, there are six different costs. And the last instance shown in the graph, there are four different costs. How do you account for this? There is randomness. So you can express this unpredictability by using a random component called epsilon. So the equation of the house price is 25,000 plus 75 into size plus epsilon. The epsilon takes care of the unpredictability of the house cost. This is a random component, but we must include it. Maybe it's very small, doesn't matter, but please include the epsilon. So what is regression? It is a statistical measure. See, we try to make an equation. Then where there is a capital X or uppercase X, which is independent variables, and lowercase y, which is a dependent variable. And we try to forecast y from the various features. X1, X2, X3, etc. are the various features. In the example we just saw, there is only one feature, that is the area of the house in square foot. There can be many features, maybe number of bedrooms, number of car parks, and so on. But in simple linear regression, we have taken a single independent variable, and of course, the dependent variable will also always be 1. Remember, in regression, the dependent variable will be only 1, but independent variables can be 1 or many. Now let us look at what is regression analysis. We focus on relationship between the dependent and the independent variable. It's required in many cases because if you're trying to buy a house, you would like to know what is the market price. It can't be a price paid by one particular individual. So if you collect the data, then you'll be able to come with a reasonable approximation of the cost of a house in a particular locality. And regressions is widely used for prediction and forecasting. They may appear to be the same, but there is subtle difference. Regression analysis includes techniques for modeling and analyzing variables. According to a study, 50% of the problems in regression can be solved with the simple linear regression. So what is linear regression? is the simplest mathematical relationship between variables x and y. You would have studied in school to draw a straight line. You would have said y is equal to mx plus c. What is y? Y is the dependent variable, m is the slope, and c is the intercept. C is a constant. Okay? So this is a kind of a cause and effect relationship. The independent variables are the causes, and the effect is the dependent variable. The first order linear model is given by y is equal to b naught plus b1x plus epsilon. Epsilon is a random error term which is independent of x and has a mean 0. So in the simple linear regression, we have y, the dependent variable, we have x, the independent variable, b naught is y-intercept, b1 is the slope of the line, epsilon is the error variable. What is the slope of the line? It is a change in y for 1 unit increase in x, dy by dx, delta y by delta x. And y-intercept we get by setting x is equal to 0. So where y cuts the x-axis, that's the intercept. These are the two, I would say, the parameters of the model, where x and y are variables, whereas the slope of the line and y-intercept are the parameters. And epsilon, as we discussed, it is the error variable. Dear viewers, please subscribe to the channel if you like it. It's absolutely free. That's all for now in this video. Until we meet next time, bye-bye. Thank you for watching.